All right, so now that we have looked at our review of numbers, we're going to go ahead and do our review of algebra. And in this next section, we're going to look at expressions, equations, formulas, and inequalities. In this first video, we're going to talk about evaluating and simplifying expressions. All right, so just a quick review of some vocabulary. The first one we have is expression. An expression is a combination of numbers, variables, and mathematical operations. And by mathematical operations, we mean add, subtract, multiply, divide. How are they being connected? A variable is something that can vary in value, and variables are represented by letters. We also have constants, and constant is something that doesn't vary in value. And so mathematically, the constants are represented by numbers. And finally, we have coefficient. The coefficient is the number part of a term. And so we'll kind of go through these as we look at our examples. So when dealing with expressions, there's two things that we do. The first one is evaluating expressions. In order to evaluate an expression, we want to replace each variable with its value and then simplify using order of operations. And just remember, order of operations is please excuse my dear Aunt Sally. All right, so let's go ahead and look at example A. We have 3x minus 5y, and we are told x is equal to -7 and y is equal to 2. So the first thing we want to do is replace each variable with its value. So wherever I see an x in my expression, I'm going to replace it with a -7. We have y equals 2, and so wherever we see y, we want to replace it with a 2. And then we want to simplify following order of operations. Here, the first thing that we want to do is multiply. If we multiply 3 times -7, we get -21. And if we subtract 5 times 2 is 10, and so we get -21 minus 10. We want to simplify it as far down as possible, and we can combine these. And so here we do have same signs, so we are going to add and keep the sign, and we get -31. All right, let's try a couple more. If we come to example B, we have 2 times x plus 1 squared minus 10. So same thing again. In order to evaluate, we want to replace x with -3. And when we plug that in, we get 2 parentheses -3 plus 1 squared minus 10. If we follow our order of operations, the first thing we want to do is parentheses. We want to simplify inside parentheses. We get -3 plus 1 is -2. I'm going to bring down everything else. We want to simplify our exponents, and so if we square -2, we get +4, because this is -2 times -2. We want to do any multiplyings, and so we get 2 times 4 is 8. We bring down our -10. And then finally, we have different signs, so we are going to subtract, keep the sign of the larger number, and so we get -2. All right, let's keep going and see what else we can do. If we come to example C, we have 8a squared divided by 5b minus 4 plus a. So again, here we have two values, and so in my expression, wherever I see an a, I want to replace it with a 5, and wherever I see a b, I want to replace it with a 2. So we have 8a squared, and so I'm going to replace the a with a 5, divided by 5 times b. Here we have a b, so I want to replace it with a 2. Bring down our minus 4. And then it says plus a, and again we want to replace a with 5. From here we want to simplify using order of operations. And so I don't have anything that technically counts as parentheses, because there's nothing to simplify inside the parentheses. We do have an exponent, and so if we square 5, we get 25. I'm going to leave this alone for now, even though you can go ahead and multiply this if you want at this stage, because it's not connected to anything else. All right, that takes care of exponents. All right, if we do our multiplyings and our dividings, we want to go from left to right. And so here we are going to go 8 times 25, which is 400. Now this is one where I'm not really sure, and I'm going to have to double check the book, because technically we should divide next. But the way it's written up above, I'm not sure if they want to divide or multiply first. But I'm going to go according to order of operations. An order of operations says multiply and divide from left to right. So do not multiply 5 times 2. If we wanted to do that, then we would have had parentheses around the entire 5b. If we do 400 divided by 5, we get 80. We want to multiply that times 2. We get 160. And then we want to do our addings and subtractings. And so here, just so you know, adding and subtracting, you can do this in any order technically, as long as you remember that that minus 4 is a negative 4. And so, for instance, you can go ahead and combine negative 4 plus 5 and get 1. And if we add that together, we get 161. If you want, you can also do 160 minus 4. That is going to be 156. And if you add 5 onto that, you do get 161. And so this one, it does not matter. On the other hand, if you go back to the division and multiplication from left to right, if you multiply 5 times 2 first, you will get a very different answer. And so that's one of the ones where you have to be very careful. All right, so let's see here. I think those are all of the examples that we have. All right, so this is evaluating expressions. The other thing we want to look at in this section is we are going to talk about simplifying expressions. And the main difference between simplifying and evaluating is in evaluating we plug in numbers and we get an answer equal to a number. When we talk about simplifying, this is not the case. We're going to keep our variables around. And so our rules for simplifying expressions, the first thing that we want to do is distribute to clear the parentheses, and then we are going to combine like terms. Now, like terms are terms that have the same variables, and those variables have to have same exponents. Another way to think about it is everything after the coefficient, the number in the front, must be exactly the same. All right, so let's look at some examples of this. If we come to example A, we have 3a plus 5a squared minus 7a plus a squared. We don't have any parentheses, so we don't have to do any distribution. And so we just want to combine like terms. Now, when we combine our like terms, we do need to be careful because we have some of these have exponents and some of them don't. And so, for instance, here our 3a can combine with our negative 7a. They are both a terms. And so in order to do this, we're going to combine our coefficients. We're going to ignore the a for now, so we have 3 and negative 7 combined to give us negative 4, and then we keep our a. All right, is there anything else that we can combine? And we can. Here I have a 5a squared, and it can combine with a squared. And just a reminder, if there is no number in front, it is implied to be a 1. And so again, we add our coefficients and we get 6. We keep our variable and we keep the exponent. You can think of the variables when simplifying, you can think of them kind of as units. If you want, assign words to them, apples, bananas, whatever you want to in order to make it a little bit easier. Now from here, we cannot combine anything else because a and a squared, these are not like terms. And so my final answer is negative 4a plus 6a squared. You can also write this as 6a squared minus 4a. And we'll get into that when we get into polynomials. All right, let's look at a couple more examples. Let's come over to example B. In example B, we do have parentheses, so we do need to distribute. And so distribute means that everything inside the parentheses needs to be multiplied by whatever is on the outside of the parentheses. So here I have 2 times 5a, which is 10a. I want to multiply 2 times minus 9, and that is going to be minus 18. And that's our first one. The second one, we want to multiply 3 times 4. We get plus 12. The plus is coming from this one right here. We have 3 times negative 5a. This is going to be negative 15a. And then we have 3 times 2, which gives us plus 6. That's our distribution step. Now we have our combining step. So, what terms are like? We have 10a can combine with negative 15a. We have different signs. We have a positive and a negative, which means that I want to subtract. I want to keep the sign of the larger number, and I want to keep the variable. All right, we can combine all of our constants together. And so here we have negative 18 plus 12. This is different signs, so we subtract. We keep the sign of the larger number, and that is negative 6. And if you want, you can do this in 2 steps or 1. I'm going to bring down my other 6. And now if we combine negative 6 plus 6, these cancel. And so my final answer is negative 5a. And we're done. All right, let's come down to another example. We have C for minus 5 times x minus 2. And so here we do want to start with our distribution. And the important thing to remember is that because we do have this negative sign here, make sure that you also distribute it with the 5. And so I'm just going to bring down my 4 for now. It does not have to distribute to anything because it's separate from the parentheses. If we distribute, we get negative 5 times x is minus 5x. And if we distribute negative 5 to negative 2, this becomes plus 10 because we have two negatives. All right, we want to combine like terms. We can combine 4 and 10. We get 14 minus 5x. Or you can write this as negative 5x plus 14. These two terms cannot be combined. They are not like. One of them is a constant term, the 14, since it has no variables. And the second term is an x term, so it can only combine with other x terms. Our final answer is negative 5x plus 14, or 14 minus 5x. Either one of these is correct. All right, last example. We have 6 minus, inside parentheses, 3 minus m minus n, and then minus 5n. So again, the first thing we want to do is distribute. And here, because we have just a minus in front, we want to distribute the negative. And if you need to, remember that this is basically negative 1 times all the stuff that's in the parentheses. So when we distribute, we get 6. We get negative 1 times 3 is minus 3. We get negative 1 times negative m is plus m. And we get negative 1 times negative n is plus n. And we bring down our minus 5n. If you want, you can also think of this as, okay, we want to subtract 3. We want to subtract negative m. And remember that minus a negative becomes a plus. And we want to subtract negative n, or again, when you subtract a negative, you change it to a plus. All right, from here we want to combine our like terms. And so we can combine our constants together. 6 minus 3 is 3. Plus m. M does not have anything to combine with. And so we are just going to bring it down. And then we have plus n and negative 5n. We can combine these. We have different signs, so we are going to subtract, keep the sign of the larger number, and keep the variable. And so this is our final answer. We cannot combine anything else. There are no more constants that I can combine with 3. There are no other terms that contain m's that I can combine with the m. And there are no other terms that contain n that I can combine with the negative 4n. And so this is considered a simplified expression. All right, so real fast, how are we going to apply this moving forward? Evaluating expressions. We use these concepts whenever we work with formulas. For instance, formulas involving geometric shapes like perimeter of a rectangle, area of a rectangle, the distance formula, You have lots of formulas that you've probably seen up till now. In terms of algebra, two of the main things that we use evaluating for is, for instance, when we use the formula for slope. We'll see that one later this module. And we will also be using the quadratic formula later this semester. We'll be extending these concepts when we find points to graph various types of equations, and also when we evaluate functions. Simplifying expressions, we use this quite a bit. We use this when we simplify more complex expressions. Later this semester, we're going to talk about quadratic and polynomial, rational, radical, exponential, logarithm, and we use these ideas there. We also use these when we talk about solving equations. Again, these are all the different types of equations that we're going to look at. And when we combine functions. All right, so that takes care of our evaluating and simplifying. In the next video, we're going to talk about solving equations.